talking about the trigonometric ratios of 45, 45, 90 triangle by the use of the acronym SOHCAHTOA, we'll be able to identify the six trigonometric ratios for this special right triangle 45, 45, 90. So, of course, in our reference angle, whatever angle that we use, either A or C, will have same angle measures, which are 45 degrees. So, whichever angle that we use will still end up with the same result because we have two congruent angles here, angle A and angle C are congruent since they are both 45 degrees. In our previous video, we have identified that if A is equal to 1, then the hypotenuse will be square root of 2. So we'll retain that as it is. If our reference angle is angle A, opposite of A is 1. So this is the opposite side. And then this is the adjacent side. But as you can possibly observe, the opposite side and adjacent side are equal, which measures 1 unit. So that is just easy to identify. So let us proceed with the three basic trigonometric ratios, which are the sine, cosine, and tangent. If we are solving for sine 45, that means we need to use the acronym SO. So that is opposite over the hypotenuse. Opposite of 45 degrees is 1, and the hypotenuse is square root of 2. And by rationalizing the denominator, if we are going to multiply square root of 2 over square root of 2 on the numerator and the denominator, we'll end up with 1 square root of 2. 1 times square root of 2 is simply square root of 2 all over square root of 2 times square root of 2 is square root of 4. This is a perfect square, so that will be square root of 2 over 2. As you can possibly observe, we are rationalizing the denominator in a sense that we make it as a perfect square. So as you can see, there is no radical symbol on the denominator. Now let us proceed to the cosine of 45 degrees. So cosine is from the acronym CA. So cosine 45 is adjacent side 1 over square root of 2. And still, by rationalizing the denominator, this is the same as the sine 45 degrees. So this is still the square root of 2 over 2. Since it happened that the adjacent side is 1 and the opposite side is 1, we ended up with the same value for sine and cosine of 45 degrees. Now, let us identify the tangent of 45 degrees by using this acronym TOA. So that is opposite over adjacent. Opposite side is 1, adjacent side is 1, so that is 1 over 1 or simply 1. And then we shall proceed with the cosecant of 45 degrees. And as we know, cosecant is the inverse of sine. So that means we need to take the inverse of 1 over square root of 2. So that will be square root of 2 over 1 or simply square root of 2. And then next we will solve for the secant of 45 degrees, which is also the same with the inverse of the cosine of 45 degrees. So we'll take the inverse of 1 over square root of 2. And of course, as you can possibly observe, the answer will be the same as the cosecant of 45 degrees, which is square root. And last but not the least, the cotangent of 45 degrees is the inverse of the tangent, which is 1 over 1, or simply still 1. The inverse of 1 is 1. So there you go, ladies and gentlemen. This is the 6 trigonometric ratios of the 45, 45, 90 triangle. Okay, so if we are going to write the sixth trigonometric ratio on the summary table, we'll be able to find out that the sine and cosine of 45 degrees are equal, which is square root of 2 over 2, together with the cosecant and the secant of 45 degrees, which is square root of 2, and last but not the least, on the tangent and the cotangent of 45 degrees, that will be equal to 1.